Okay, so welcome to your first video on linear relations. So this is just going to be a bit of an introduction, and it might be a bit of review from things that you've done in year 8. Okay, so the first thing we're going to remind ourselves about is this sort of grid here, okay, and this is called the Cartesian plane, okay, so it was named after a French mathematician called René Descartes. He came up with this way to organize points. So this is the Cartesian plane, and it's divided into what are called 4 quadrants. And it's divided by 2 axes. The vertical axis here, this one going up and down, is the y-axis. And the horizontal axis, going from left to right, is the x-axis. And the point where those 2 axes meet, so this point right here, is called the origin. And that's the point 0, 0. Okay, so we're just going to review how you plot coordinates on a Cartesian plane. The first one here is the point 3,5. So you've got to always remember that coordinates are always written in the form x, y. So the x value is first and the y value is second. So the point 3,5, if we start at the origin, that means we're going to go to the right 3 and up 5. So that would be point A there. Point B is negative 2, 1. So again, we'll start at the origin. Negative 2 means we're going to go to the left 2 and then up 1. So there's B. The point C there is negative 1, negative 4. So left negative to negative 1 and then down to negative 4. So that's C. And D is the point 3, 0. So we're going to go to the right 3 and we're not going to go up or down because that's the point 3, 0. So that's on the x-axis. So that's point D there. Okay, so a linear relation is a set of ordered pairs, so a set of points that when you graph, you get a straight line. Okay, so that's what we're going to be looking at in this unit. We're going to be looking at just straight line graphs. Okay, and these relations can come in generally in one of 2 forms. Okay, so the first form we're going to look at, and we're going to use a lot, is the form y is equal to mx plus c. Okay, y and x stay in the equation, so you can see an example down here. I've got y is equal to 2x minus 1. So m is going to be a number, a value, and that tells us the gradient or the slope of the line. So it tells us how steep the line is, and we'll look at that a bit more later on. And c gives us the y-intercept. So that is where the line crosses the y-axis. Okay, let's take a look at how we graph a line if we're given its equation using what's called a table of values. So I've set up a table here for you, and this question says we're going to use the values of x from negative 2 to 2 to plot the graph y is equal to 2x minus 1. So what we do is we take our x values and we substitute them into the equation of our line. So for example, for the first one here, I need to substitute minus 2 into that equation. So y is going to be 2 times minus 2 and then take away 1. And that's going to give me my value of y. So 2 times negative 2 is negative 4. Take away another 1 is negative 5. So the first point on my line is the point negative 2, negative 5. Okay? Now what I would suggest is when you go to do your table of values, if you just set this up first of all, wherever you see an x in the equation of your line, just put brackets in. So that means you're always doing 2 times whatever x is minus 1. That's our equation. 2 times whatever x is minus 1, and 2 times whatever x is minus 1. And then you can go ahead and put your x values in. So for this second point here, the x value is negative 1. So I'm going to do 2 times negative 1, and then take away 1 from that, which gives me negative 3. So I get the second point there being negative 1, negative 3. My next value of x is 0. So I can do 2 times 0 minus 1. That gives me minus 1. So my next point is 0 minus 1. Now I'm going to put in x is equal to 1. So 2 times 1 minus 1 gives me 1. Okay, so my fourth point is 1, 1. And then my last one there, x is equal to 2, so 2 times 2 is 4 minus 1 gives me a y value of 3. So my last point is 2, 3. And then I can go ahead, now I've got 5 points. You actually only really need 2 points to make a line, but it's always good to do more than 2 just to be sure. Well, I'm going to go ahead and plot these points. Okay, so my first one was -2, -5, which is here. The next one is -1, -3. Then I've got the point 0, -1, 1, 1, and the point 2, 3. And you can see there that all 5 of those points are in a line. Now, if one of them wasn't in a line, you've probably made a mistake. So you should go back and check your substitution on that point. Okay, so using a ruler, you can connect the dots, and my line isn't very straight because I haven't used a ruler, but I'm sure all of you will. And I can label that. Now I've drawn the line y is equal to 2x minus 1. So you can see with this topic, we are actually combining things that we know about algebra with geometry. That's what this coordinate plane allows us to do. Now I put a question at the bottom there, and it says, as the value of x increases, what happens to the value of y? So if we look back to our points that we plotted, we can see that the x value is going up by 1 every time because we've just picked those points in order, -2, -1, 0, 1, and 2. Now if I look at the values of y, my values of y, if I go from -5 to -3, I'm adding 2 there. And if I go from -3 to -1, I'm adding 2 there as well. -1 to 1, I add 2. And 1 to 3, I add 2. So this is what happens in a linear relation. All the y values will go up by the same amount. And you might notice here, they're all going up by 2. Now, do you see any 2's in the equation of our line? Hopefully you do. That is actually our gradient. Okay, so that tells us that all of our y values are going to go up by 2, okay, for every x value, because what I'm doing is I'm multiplying x by 2 all of the time. Okay, so that's just something to notice. It might come in handy to see that later. Okay, so this example you can go ahead and try on your own. I'm going to do it, but I'll kind of speed up the video so you can just follow along, or I'd recommend just stop the video and try and work it out on your own. First thing I'm going to do is I'm going to fill in my values for x. So in the question, I'm told to use for x the values again between -2 and 2. So -2, -1, 0, 1, and 2. Okay, and then I'm going to set this up again just so it's easier for me to calculate. My equation now is -3 times whatever x is plus 1. Okay, so now I'll go ahead and substitute in my values for x. So now be careful, this time I'm doing -3 times -2, which gives me +6, plus 1 gives me a value of 7. So my first point there is -2, 7. Now I'll go ahead and do the rest. Okay, so once you've got all 5 of your points, you can go ahead and plot those on your Cartesian plane. Okay, so this time, when we look at what happens to the value of y as x increases by 1, hopefully you can see this time what's happened is you've had to subtract 3. So every time x goes up by 1, y goes down by 3. Okay, and again, you can see that represented in the equation up here. Y is equal to -3x plus 1. Okay, so again, that's the gradient. It tells us the slope of the line. So in this case, the gradient is -3. Also, what you can see here is that the line is going down. So from left to right, That's because we've got a negative gradient. So if we look back to the one we did before, you can see that this one had a positive gradient, had a gradient of 2, and this line is going up from left to right. So, okay, now we're going to try and go backwards. I've given you these points, and you're going to try and work out what the linear relation is. So, in this case here, we know the equation of a line has to be in this form. Y is equal to mx plus c. Okay? Now, what we can work out here is the gradient. So we can look at, as x is kind of going up by 1, okay, in this direction, we can look at what's happening to y. So in this case, to go from 5 to 4, we have to subtract 1. And then to go from 4 to 3, we also subtract 1. From 3 to 2, subtract 1. Subtract 1, subtract 1. So we can see that what's happening here is that we're taking away 1 every time. So that means our gradient is going to be 1. Okay, so I've kind of got a bit of my equation. I'm going to have y is equal to negative 1x plus c. But I need to work out what c is. And c is the y-intercept. So it's where the graph crosses the y-axis. Now, if we look back to this one here, you can see that the graph crosses the y-axis at this point here, right? At the point 0, 1. So the graph's always going to cross the y-axis when x is equal to 0, right? Because it's going to be on that line there. So the x-coordinate of any point on that line is always going to be 0. And from my table of values, I could have seen that without even looking at the line because I've got this point here, 0, 1. So I know my y-intercept is 1. So if we go back to this here, take a look at the table of values and see if you can find the y-intercept. So remember, the y-intercept is when x is equal to 0. So it's going to be that point there. Okay, so the graph crosses the y-axis at the point 0, 2. So the y-intercept is just 2. Okay, so that means c in this case, so the y-intercept is 2. So I can finish off the equation of my line. I've got y is equal to negative 1x plus 2, or we don't usually write in negative 1 when we've just got the line y is equal to negative x plus 2. Now I mentioned in the beginning of this session that we could have the equation of a line in a different form. We could also have it in the form ax plus by is equal to d, where a, b, and d are just numbers. So if you take a look at this here, I've got negative 4x plus 2y is equal to 6. Okay, so it's in a different form, but it's actually really useful for us to put lines in the equation y is equal to mx plus c, because we can then immediately tell what the gradient of the line is and what the y-intercept is. So we need to go back to our ability to rearrange a formula that we learned in our algebra unit. So be able to make the y the subject so that it's in the form y equals mx plus c. So let's take a look at this first one here. So I want y equals on the right hand side. I don't want that minus 2x in. So what I can do is I can add 2x to both sides, and that gets rid of it on this side, which gives me y is equal to 5 plus 2x. Or I can swap those around and just write 2x plus 5 because they're both positive. Okay, let's take a look at b. So b in this case, again, I want y on its own. So the first thing I'm going to do is add 4x to both sides. Add 4x, add 4x. That gets rid of it here. So I'm left with 2y is equal to 6 plus 4x. Okay, but I don't want 2y, I want y on its own. So what I have to do is I need to divide every single term by 2. So on the left-hand side, I get y on its own. Now if I do 6 divided by 2, I get 3, and 4x divided by 2 is 2x. So now I've got this in the equation y is equal to mx plus c. Okay, so that was the end of this video. You can go right ahead and write your summary and your question. If you know the answer to your question, you can fill that in, but if not, you can just leave it blank for our class.